would like to explain about the Queue ADT. Right, in your previous video, we are detailedly discussed about what is a queue and what are the ADT operations we are going to be performed. Friends, we know that queue is a linear double-ended data structure which has the two pointers. One is the front and another one is the rear. So here I am going to be named this one as queue. And we know, friends, the addition of the elements into the queue is happen at the rear and removing of the elements are performed from the front. Because let us consider, we are going to be consider any general queue. Suppose we go to a cinema hall, right? The first person is in front of the queue. Behind him, that means at the rear point of him, the second object or the second person is there, and at the rear position of the second person, third one is there. At the end, rear position of the third one, the fourth one is there, is like that. And at the end of the fifth person is there. So whenever the first person get the ticket, suppose he is removed from the front. When the second after that, when the second person get the ticket, he is removed from the front. So insert or NQ is performed at the rear end and DQ, that means removing of the elements, is performed from the front end of the queue. Okay friends, here I am going to be try to implement the queue by using the array. We know that the array is also a linear data structure in which all the elements are stored in consecutive memory locations and array is indexed by the unique number start from the 0, right? So before in the 0 position also we store the elements. So for that reason I initialize front value -1 and rear value is also be -1. So to perform the insert, so I am going to be improve the or increase the rear value. Rear is assigned to rear +1. Now the rear value equal to 0 and the element may be A. Let us consider. Now I write Q of rear equal to element. Now the A is added here. To add one more element, I repeat the same code. Rear equal to rear +1. Now the rear value equal to 1. The element may be the B, right? Element equal to Q of rear. The B is added here. So, okay friends, in this way I am going to add it. When the queue is full means when rear equal to or rear reaches to the maximum size of an array, if this is the condition, the queue is full. In the same way, to remove the elements, I am going to be increase the front equal to front +1. Now initially the front value is equals to -1. Now -1 plus 1, that equal to front value equal to 0 and the element I am going to be get the data q of front. So the q of front, that means q of 0 equal to A is extracted and I am going to be print A. That means the A value is printed. When the queue is empty means again we are going to be observe that. So before suppose it's 0 and this is the 5 or 4 maximum size, I'm going to be consider 4. So when front equal to rear, that means -1 equal to -1. So at this position, no elements in the queue. Now queue is empty. Suppose there are the elements in the queue, right? And we are improving the front. we remove this one and we remove this one, but from the front we remove this one and we remove this one, and we are here. That means again here also front and rear are the same. That means front equal to front plus 1. Front move one position forward when we remove the elements from the queue. Here also front equal to rear. Front equal to rear equal to maximum size here. In this condition also queue is empty. Okay friends, I will write the algorithms for the following Queue ADT. So in the Queue ADT, we are going to be consider these 5 algorithms. One is the Queue ADT, I write. One is the create queue. The second one is the, we are going to be check is full. The third one we are going to check is empty. The fourth one we are going to write Enqueue. The fifth ADT algorithm we will write DQ. Okay friends, now I am going to be create a queue. Here I write the algorithm void create underscore queue. So to specify the size of the queue, I am going to be take maximum size or int size equal to 5, and I am create a character QUE of size, and I initialize the pointers int front equal to -1 and int rear equal to -1. So we can observe friends by this one. Actually, one queue is created with 5 elements. This is the 0, 1, 2, 3, and 4, because the maximum size is 5. So this is the 5, and the front and rear are here. For simplicity, I going to call it as F and R equal to -1. So this is empty queue. Okay friends, now I would like to check whether the queue is full or not. So for this one, I write a code void is full. We know that we add the elements from the rear. When rear reaches to the maximum size, the queue is full. So for this, I am going to check if rear equal to max size. That means size -1, because I am going to take size equal to 5, size -1, 4, right? Print queue is full, right? So this is the simple full to check whether the queue is full. Again, I write one more. Queue is empty. We can observe that when queue is empty, when front and rear are at the starting position, or suppose we remove the elements from this front, we are increase the front, and when the front and rear are at the maximum size. Right, again F and R equal to size. This is also the empty. So whenever front and rear are equal, the queue is empty. So for that reason, I am going to write one more algorithm void is empty, right? If front equal to rear, simply print queue is empty. Queue is empty. Okay, friends, this is the right. algorithms for to check whether the front and rear are queue is full or empty. Now I will write one more algorithm for Enqueue. Before I write the algorithm for Enqueue, right, we are going to be consider an empty queue here. So this is the empty queue. So this is the 0 position, 1 position, 2 position, 3 and 4th position, and front and rear equal to -1. We add the elements at the rear. So now I write void Enqueue. So to enter the element, I am going to be take the element print enter element. Now we read the element, read element, okay, and then I'm going to be include the rear equal to rear plus 1 and write queue of rear is assigned to element, okay. Please cancel the front, enter the element. The element is A. A is readed, rear equal to rear plus 1. That means rear value equal to 0 and Q of rear equal to element. Now the A is added here. To add one more element, again we call this function Enqueue, print enter the element. The element is B. Again rear equal to rear plus 1, rear equal to 1, Q of rear, the element is added here. In this way, now presently the rear value is here. Right? Suppose we add one more element, the C is here and rear is here, like that. Okay. Now we are going to be observe how we are going to be remove the elements from the front. Okay, for that reason, again I am going to be consider a queue. So this is the 0 position. In this position I am already add A. This is the first position. Here I am already at B. This is the second position. I am already at C. Now the rear is here and front equal to -1. Right? Now I write the algorithm void dequeue. Right? I am going to be check how to remove. That means element equal to, sorry, first I am going to be improve the front value. Front equal to front plus 1. Now the front value equal to f value equal to 0 and element equal to q of front. That means the element is q of front that equal to a, and I print that element, print element. That means a is printed. Okay friends, now the A is printed from the 0th position. To remove another element, now the front value again incremented and element Q of front, Q of 1. So here we observe that now the front is here. Q of 1 equal to B, the B is printed. Suppose we are going to again element 2, actually the C is printed. Now the front is also be here. Right, whenever the front and rear are equal, queue is empty. That means all the three elements are removed from the queue and queue is empty. Okay friends, I hope we can understand these algorithms. Thank you.